Hi, this is analyzing the relationship between urban energy consumption and the urban heat island effect by Michael Raziel and Jason Liu. To start off, the urban heat island effect is the phenomenon in which urban areas experience significantly increased temperatures when compared to surrounding areas due to human development. Land surface temperature is the measure of the heat emitted from the surface of the ground. This type of data is important as it aids in urban heat island identification. Energy use intensity is a metric that is utilized to determine the energy efficiency of a building. It is calculated by dividing the annual energy consumption of a building by its gross floor area. The lower the energy use intensity, the more efficient a building's energy use is. Energy star score is the metric that takes into account the operations of the building in order to determine its energy consumption. The higher the score, the better the energy performance. This project aims to define the relationship between urban heat islands and the energy consumption of buildings. By analyzing the relationship between LST and EUI, we can better understand the factors to take into account when studying the urban heat island effect to more accurately model the effect and its plausible solutions. In this study, we had two main research questions. The first is, how does energy consumption in areas affected by the urban heat island effect compare to energy consumption in areas less impacted? And the second is, how does energy efficiency of buildings around New York City impact the urban heat island effect in the areas around those buildings? And here are two related papers to our research. The first is Urban Heat Island Impacts on Building Energy Consumption, a review of approaches and findings. This is a meta-study on the causality of UHI in urban settings on energy consumption. Since cooling technology requires energy, UHI leads to energy consumption. The second is residential cooling loads and the urban heat island effect, the effects of albedo. This study investigates how increasing the albedo of surfaces can reduce the urban heat island effect, lowering energy demands that result from residential cooling. They suggest that surface reflectivity is a factor in cities that can help decrease energy consumption.
So for this study, we decided to use New York City as the study area due to its proximity and the extent of its available data. We used two main data sources. The first one was the Google Earth Engine. In the Google Earth Engine, we extracted LST data from New York City from the summer data from 2022 in order to avoid seasonal temperature variation and cloud coverage. We also used the NYC Open Dataset for EUI. We specifically used the 2022 NYC Open Data Property Dataset. Weather normalized source EUI was utilized as the energy metric, as it takes into account as many confounding variables as possible. This metric adjusts the energy use of a building based on typical weather conditions. We also used the Energy Star score to measure the energy efficiency of a building. After we had the data, we loaded it into ArcGIS. Using the geographic coordinates that each dataset provided, we were able to map the EY plus Energy Star score and the LST as two distinct layers. We then conducted a spatial join in ArcGIS to merge the two layers based on geographic proximity. The two graphs below show the LST and EY, and the graph to the right shows the combined layer. We were able to extract this layer as a single CSV file with the paired LST and EY based on the geographic coordinates. We loaded the CSV file into SPSS and got rid of any missing values. After cleanup, we were left with a sample size of n equals 5,284 viable coordinate location for each variable. We then conducted two bivariate correlation analyses, EUI versus LST and Energy Star score versus LST, to test whether these variables had significant relationships. So these are our findings. There is a significant positive relationship between the LST value and the EUI value for properties in the NYC area. As you can see, the Pearson correlation has a correlation of 0.59 and a significance that is less than 0.01, showing a significant correlation. Our second finding is a significant negative correlation between the Energy Star score and LST of a building. This indicates that the overall efficiency of the building's operations are also directly impacted by the overall average land surface temperature of its location. Again, we have a Pearson correlation of negative 0.56, which is a significance of less than 0.01.
All right, and in this study, there were several limitations. The first is that the Google Earth Engine CSV coordinates didn't match the exact location of the properties, meaning estimations had to be made for the locations. The joint therefore had to be defined by the closest rather than the exact location. Additionally, this study was conducted only in New York City, so it cannot be generalized to other urban areas or the general relationship between EUI and LST in urban areas, just New York City. This study cannot completely account for other factors that may affect energy consumption. For example, different buildings use types have different energy needs. Although the EUI is weather normalized, the LST dataset was for the summer months while the EUI dataset was annual, possibly causing other factors to influence the study's results. In conclusion, there is a correlation between the EUI and LST of areas within New York City. This indicates that the urban heat island effect has a direct impact on the energy consumption of buildings in the area. This likely is due to the increased heat the effect has, which leads to increased energy usage on cooling measures. Properties that are impacted by urban heat islands are therefore less energy efficient. To continue this research, we can take into account measures that reduce energy consumption, such as LED lighting, and the impact that the reduced energy consumption has on the average land surface temperature. We thank the NASA SEAS program for the opportunity to use real-world data and the guidance of field experts in studying the urban heat island effect. The mentors, guest speakers, and directors all were crucial in helping us reach our potential as young researchers. This hands-on experience taught us the importance of critical thinking and problem-solving in research beyond just understanding software. We developed essential skills for research, which we are eager to use in the future. And here is the abstract for our entire thing. Thank you.